Hello everyone. In this video, we'll be solving questions 21 to question 30 from chapter 2 describing motion. First, let's take a look at question 21. Four balls with different masses are dropped from the height shown. Air resistance may be ignored. Which ball has the smallest average speed? Now, the average speed of the ball increases with height. So it's irrespective of the masses because air resistance is ignored. So whichever object which is falling from the highest uh, region will have the largest speed. So in this question we have to find the one which is having the lowest average speed or the smallest average speed. So the smallest one will be this object which is falling from 1 meter height. So it's option A. Let's look at question 22. A cyclist rides 300 meter up a slope in 50 seconds. She then rides down the slope in 25 seconds. What is her average speed for the whole journey? So, average speed is given by the total distance traveled over total time taken. So, here it's total distance traveled over the total time taken. In this question, if the cyclist goes up the hill and the hill's distance is 300 meter and comes down the hill, so the distance again is 300 meter. The total distance traveled by her is 600 meters over the total time taken is 50 seconds while going up and 25 seconds while coming down. So it's 75 seconds. So 50 plus 25, which is 75 seconds. So let's input these values in our calculator. So we can take 600 over 75, and that is 8. So the answer would be the answer would be 8.0 meter per second. So the correct answer is option 2. Option B, 8.0 meter per second. Let's look at question 23. A ball hits a bat with velocity of 30 meter per second and leaves the bat traveling with a velocity of 20 meter per second in the opposite direction. The ball is in contact with the bat for 10 seconds. What is the magnitude of the acceleration of the ball while it is in contact with the bat? So here we have a ball which is first traveling with speed of 30 meter per second. Now it hits a bat. So let's say then it travels back with the speed of 20 meter per second. If I have to write my initial velocity and final velocity, the initial velocity of the ball is 30 meter per second. The final velocity of the ball should be minus 20 meter per second, because I have taken this as my positive axis. So if it's going in the opposite direction, it has to be taken as negative. If I use the formula for acceleration, which is A equals V minus U over T, where V is the final velocity, U is the initial velocity, and T is the time taken. So final velocity is minus 20, initial velocity is 30 over 0.1. So that was the time it was in contact. So it is minus 50 upon 0.1. This can be written as minus 500 meter per second square. But we should only find out what is the magnitude of acceleration. So the magnitude of acceleration is only 500 meter per second square. The correct answer is option D. Now let's take a look at question 24. A ball is thrown vertically upwards through the air. The air resistance acts on the ball. Which graph shows how the speed of the ball varies with time? When a ball is thrown vertically upwards, the air resistance acts downwards. So the direction of air resistance, if I look at all the forces which are acting on it, so the first force which acts on it is gravity. So the gravity acts downwards. Then we will have the air resistance. Then the air resistance also acts downwards. This is very important. So there is one more force that acts downwards. Okay, that is air resistance. Because air resistance always opposes motion. If the direction of motion is upwards, then the air resistance will act downwards. If the direction of motion was downwards, then the air resistance would have been upwards. In this question, we have to observe what would happen to the speed of the ball. The speed of the ball will gradually decrease and it reaches 0 at the highest point. So in these graphs, we know that the air resistance is non-uniform because air resistance depends on the speed. As speed increases, the air resistance increases. In these questions, we can eliminate option A from the options because here the acceleration is a constant in both the cases, which is not true. Then between option B, C and D, we can eliminate option C because as the object is falling down, it eventually attains the terminal velocity. So it will reach a constant velocity like this. So what we are writing here is speed versus time graph. It will eventually attain terminal velocity. And so option C can be eliminated. Between option B and D, let's look at what is happening to deceleration. As the object is moving upwards and reaching the highest point, the acceleration on the object reduces. So because the air resistance is reducing as the speed is reducing. So in this case, look at the slope here. The slope here actually increases, which implies the deceleration is increasing, which is incorrect. Right? The deceleration reduces on the ball, and at the highest point, the speed is 0. And while it falls back towards Earth, it will attain terminal velocity. So the correct option is option D. Question 25. Two rockets are launched at the same time from the surface of Earth. The graph shows how the speed of the rocket change with time. Which statement about the rockets is correct? We have rocket P and rocket Q. So let's look at option A. Both rockets travel the same distance. In a speed time graph, distance is given by the area under the curve. So if I want to find what's the distance traveled by rocket P, I have to find what is the area under this curve for rocket P. So here, if I calculate what is this area, that would be equal to the distance which is traveled by rocket P. Whereas for rocket Q, This is the distance traveled. Let me use another method to do this. This is the distance traveled by rocket Q. So clearly we can see that rocket P has traveled larger distance than rocket Q. So option A is incorrect. Rocket P accelerate and then decelerate. Decelerate means the gradient should be negative. So deceleration means negative gradient in speed time graph. If we observe the speed time graph for rocket P, there is no negative gradient so far. So here the gradient is always positive. Here the gradient is positive, this is positive. So everywhere the gradient is positive, so it is not decelerating. Let's look at option C. Rocket P travels further than rocket Q. This is true. By looking at the area curve under the curve, we can conclude that rocket P travels further than rocket Q. Then rocket Q has zero acceleration. This is incorrect, because the rocket Q, the speed, if you look at the speed time graph for rocket Q, there is a gradient here. There is a change in speed. Right? If wherever there is change in speed, there will be acceleration. Let's look at question 26. A train begins a journey from station and travels 60 km in 20 minutes in a time of 20 minutes. What is the average speed of the train? To determine average speed, again we have to take up total distance traveled by total time taken. If we look at the options given, the option is in meter per second. So we have to convert all our distances to meter and the time to seconds. So we have 60 kilometers over 20 minutes. We can rewrite this as 60 times 1000 meter, because 1 kilometer is 1000 meter, divided by 20 times, and 1 minute contain 60 seconds. Here we can cancel 60 and 60, and it's 1000 by 20. 1000 by 20 is 50 meter per second. So the average speed of the train is 50 meter per second, which is option C. Question 27. The speed time graph represents a journey. How does the graph show that the distance traveled in section X of the journey is greater than the distance traveled in section Y of the journey? If we consider a speed time graph, the area under the curve will give us what is the distance traveled by the graph. In section X, this is the area covered. So this is the area under the curve. So this is the distance covered. In section Y, this is the area under the curve. Between section X and section Y, section area of section X is larger than area of section Y. So if we let's look at the answer, the area below section X of the graph is greater than the area below section Y. So this will be the correct answer. Question 28. A boy throws a ball vertically upwards with a speed v. Which row describes the speed and acceleration of the ball at point X on on the way upwards. Now, if we look at point X here, the let's look at this. Now it's moving vertically upward, so its speed is gradually decreasing. So speed is decreasing, and at the highest point it will eventually become 0. If we look at the acceleration on the ball is vertically downwards, and it is purely due to gravity. So here it is acceleration due to gravity, and it always acts vertically downwards. So the correct option would be the speed decreasing and the acceleration vertically downwards. It would be option B. Question 29. A car driver measures the time taken to complete 4 separate journeys. In which journey does the driver have the greatest average speed? For this, to solve this question, we have to know what's the average speed in each of the case. Let's look at case 1. In case 1, the average speed, if I take one more column as speed, and the unit here will be kilometer per hour. For the first one, the average speed is distance by time, so it's 60 divided by 2. For this, you can use your calculators. So 60 divided by 2 is 30. For the first one, it is 30 meter per second. Sorry, 30 kilometer per hour. For the second one, it will be 60 upon 3. So it is 20 kilometer per hour. For the third one, it is 120 divided by 3. Here it will be 40 kilometer per hour. And for the fourth one, it is 120 divided by 4, that is 30 kilometer per hour. Among the 4 of them, option C will have the greatest average speed. Let's look at question 30. The graph shows how the speed of an object varies with time. Which row describes the motion of the object at times P and Q? At time P, this is the motion of the object. It's a horizontal line, and the speed of the object is not changing. That means the object is moving with continuous speed. Let's look at for time Q. At time Q, the speed of the object is increasing, which means the object is accelerating. The correct option which we have to select is option C, which says at time P, object is moving with a constant speed, and at time Q, the object is accelerating.